Dear students, now next topic, that is electric potential due to volume distribution of charges. Suppose in a particular region the distribution of charges that is given to you, and this particular distribution that is continuous distribution. So in previous chapter we studied about the electric field due to continuous charge distribution, right? So here we can easily understand how to calculate this potential. Here what we have to do, we have to use the concept like this. We have to divide this continuous charge distribution into so many infinitesimal small volume elements. Then we have to find the electric potential at a given point due to each infinitesimal small volume element, and then after we have to take the summation of all those potentials. So here suppose we consider one small volume element d tau dash, which one is at position r dash, and suppose the volume charge density that is rho at position r dash. Now volume charge density means charge per unit volume. We considered the volume that is d tau dash. So per unit volume the charge is rho, then in d tau dash how much? So now charge in that particular small volume element, that is rho at r dash d tau dash. Now due to this particular small charge, what is the potential? So we can write that potential dV, that is 1 upon 4 pi epsilon 0 q upon r. Q, that is what? So charge in that particular small element, that is rho at r dash d tau dash, upon the position of that particular point with respect to that volume element. So we can write that is magnitude r minus r dash. Now if entire charge distribution is divided into so many small volume elements, and then we find for each one the potential like this, and then if we take the summation. But here the volume elements are very small, we can consider it tends to 0, and the distribution is continuous one. So we can calculate this total potential with the help of integration of this equation over the given volume. So potential at a point having position r, that is 1 upon 4 pi epsilon 0, integration over the entire volume distribution rho at r dash d tau dash upon r minus r dash. So here if the charge distribution that is uniform one and the volume charge density that is constant one, then except taking rho at r dash, simply you can consider it as rho. Clear to all of you?